Very good morning, students. Welcome back to the SBR online classes. So today we shall see the next concept. So yesterday we have studied NPR formula, right? When all the objects were distinct. Is that clear? So today we shall see permutations when all the objects are not distinct. So just we shall recall the yesterday's class when all the objects were distinct objects were given. So what was the formula of NPR? NPR formula is n factorial by n minus r factorial, and with the condition repetition is not allowed. Repetition is not allowed. Right, students? Okay, so distinct objects means different. Every object is different in this case. So arrangement of n r things out of n things is equal to n factorial by n minus r factorial, with the condition repetition is not allowed. And we saw three cases also. So what were those? NPN is equal to n factorial arrangement, arranging n things out of n things. So it's nothing but n factorial arrangement. Second one, np0, right? So np0 is 1, right? So arranging, so we have solved them. So arranging 0, arranging nothing out of n objects is 1. Third one, np1 is equal to n, arranging one thing out of n is equal to n. Okay, so along with this we have even solved what if repetition is allowed. What if repetition is allowed? Okay, so if they are asking us to arrange n objects among r taking r at a time, right? So that will be n to the power r. So these were the few things we have understood based on distinct objects. Based on distinct objects. Okay, so now distinct means different. Do remember that. So now we shall see when there are no distinct objects. Okay, before we read what is written over there, we shall start with an example. Okay, so if you understand that example, it will be very clear for you to understand what are these two things. Okay, so now let me rearrange. So I'll give you a question: in how many ways we can arrange, or in how many ways we can rearrange the letters of the word mat? Okay, so let me start with mat. Okay, so they have given you a word mat, and they are asking us to in how many ways we can rearrange this letter. Okay, so if you observe here, all the three letters of the word are distinct, right? Means all are different objects, right? So these are nothing but distinct objects. Right? So now let me rearrange. Okay, so let us write down the arrangement and see, right? So it might be arranged in this manner, right? So let me fix m first, arrange a and t. Now let me fix m first, and still there can be arrangement among a and t, mta, right? Next, let me take a as first and arrange m and t, right? So a empty, right? So now m and a is arranged. Now t you see, right? So t m a. So these are the possible arrangements. These are the possible arrangements. So how many we can arrange them in how many ways? 6 ways. So the given we can rearrange the word mat in 6 possible ways. Okay, so we can see by the fundamental principle of counting also, box method also. So there are 3 letters, right? 3 letters, right? So now the MAT, so 3 letters have to be rearranged. Okay, so 3 letters have to be rearranged. So rearranging among three different places, right? So the first box can be filled by either M or A or T. So three ways, right, students? And the second box, okay, we are rearranging. So here you need repetition doesn't occur, right? So now this will be arranged in two and this will be arranged in one, right? And so after filling the first blocks, and I'm filling the second, and I'm filling the last one. So it's nothing but six ways. So when you list down all the arrangements, you got six ways. When you understood, when you try to simplify it by the box method or the fundamental principle of counting, you got six ways. Now let us see by the formula also, right? So what is NPR? So what are the letters given to us? Letters, how many letters are given to us in math? Three. And they have to be arranged among three places, right? 3p3. Just now we have seen what is, you can solve it, okay? You can simplify it. So what's the formula? NPR, n factorial by n minus r factorial. So this is nothing but 3 factorial by 0 factorial. So 0 factorial is nothing but 1, right? So can I say now directly? So 3p3 is nothing but 3 factorial. And what do we mean by 3 factorial? 3 factorial is 3 into 2 into 1, which is also 6. Right? Understood? So whatever tools we have studied till now. So in all the cases, the arrangement, rearrangement of mat is 6 possible ways only. Is that clear, students? But today we need to discuss regarding permutations when all the objects are not distinct. This is important now. But we understood now the example based on distinct objects. Now I have to see regarding not distinct. Okay, from this only we will derive. It will be easier. Okay, why I have first solved distinct objects, you will come to know here. Okay, so now what I will do, I'll ask you to just replace the letter T by A. So what I am doing here, just replacing capital T by A. Okay, so what happens, I'm just replacing capital T by A, the rest I'm taking the same T by A. I got A. So now we read it as ma, right? So M-A-T. In this word, all the letters are different. All the letters are distinct objects, right? So, but if you see here, the letters are not distinct, right? So a letter A is occurring twice. Okay, here A is of one kind. So you can say it is, okay. So this is nothing but, here you have one mango and two apples, right? So of one kind, right? So two apples will keep, okay, in the fruit stall. What it will be done, apples will be kept in one side, right? And mango will be kept in another side. So it's distinguishable, right? So now look here. So what I have done here, all the three letters in the word mat is distinct, different. But today we need to discuss not distinct objects. So that means all are not different, right? So here A is occurring twice. So now let us see how we will arrange this and what will be the answer of that, and why we need to understand this example before we speak about these two statements. Okay, so now what I have done, just replacing T by A, right? So wherever, so it must be, the answers must be same only, right? Three letters only. Here also three letters. What I have done, just replaced T by A, that's it, right? Nothing else. So let's see, it has to be 6 only, right? So M A. So T is replaced by A means, right? So wherever T is there, I will replace it by, right? So now you can see I'm just replacing wherever T is there, I'm just replacing it by M. So these two, M A, M A, A M M, A M M. So M A M M. Sorry. We need to replace T by A, right? A M M. Okay. So again we got 6. Right, again we got 6 arrangement. But what's the use of studying? Okay, I have told you distinct objects are different and not distinct objects arrangements are different. But we are getting 6. So what's the use of devising another two theorems? Right? So what's the use? But if you observe carefully, the arrangement of first one and the second one are similar only. Okay, so arrangements, you have that arrangements must be different, right? And that arrangements must be in a definite order. So the first one, second one are almost same. So there is no necessary, that's not required at all. And if you observe these two, these are also same, right? So if you observe, right? So the next one. Okay, wait. I'll just, so replacing T by A, right? M A A. So T by M A A M M A M A. Sorry, students. I have written replacing T by M. Wait. A M M, right? T by A. Sorry, the last one was wrong. Second one was wrong. T by A, right? Now this one A T by A, right? So now okay, let me write once again. It will be clear. Sorry. So now what I have done, MAT I have discussed. Now replace T, wherever is T is there, replace T by A. That's what we are done here, right? So now M A A, right? M A M, right? A M A, right? So this T A M and this T A M A. Now it's clear, right? So now you can observe. We got again 6 only, 6 possible ways. But if you observe very carefully, among this there are many similar type of arrangements. So that's not at all required, right? So this arrangement, the first arrangement is MAA, so it's same as the second one, right? So the next arrangement AAM is same as this one, right? So now the arrangement AMA is same as this. So how many arrangements we are left with now? 1, 2, 3. Yes, students. So our arrangement is not 6 here in case of not distinct objects. It's 6. It's not 6, right? So how many arrangements are there? The arrangements are 3. Right. So now if you observe, when all the distinct objects were there, all the letters were different, MAT. So what was the answer? 6 ways, right? 6 ways. But we just replaced T by A. So how many we got? 3 ways. Okay. When the distinct objects are there, actually what should be our answer? 3 factorial. But it failed in this case because we have a letter A which is appearing twice, right? So now, so if it was different, all the letters were different or like this, so what would be answer? 3 factorial, right? But that's not the case. 3 factorial is not the case, but we got only 3 ways. So 3 factorial means how much? 6 possible ways, but we got 3 ways, right? So we got 3 ways because of this because the A is of one kind, right? And how many are there? A's. 2A we have, right? So we have 2A, right, students? So we have 2A. So these two objects, these two letters can be arranged among themselves as 2P2, right? That is your 2 factorial. So if all the objects were distinct, our answer would be 3 factorial, or you can say 3 into 2 into 1, 6. But here, since it is not distinct and A is occurring twice, so it is occurring twice means divided by 2 factorial. Right? So now 2 factorial is nothing but 2. Right? So 2 ones are 2 threes are. So we got our answer 3 factorial ways. Okay. So whenever in the letters or in the numbers, if they give you some words or some numbers, you have to carefully check whether it is a distinct objects or a similar or not distinct objects. If distinct objects, you know how to solve it. If not distinct objects, okay. So now first, how many letters are there? 3 letters, and they can be arranged in 3 factorial. But since A is appearing twice, right? A is appearing twice. So divide it by 2 factorial. Right? So this is how you solve when a group occurs, a similar group. A group is occurring twice. Right? So still there are more examples. Okay. So for example, if you take tool, right? So how many letters are there here? There are 4 letters. If these are not distinct objects, right? So count them. How many are there? 4. So 4 factorial. But since they are not distinct, O is appearing how many times? O is appearing 2 times. So it can be arranged among itself in 2 factorial ways. Okay. So now let's suppose this is the word, right? So let's suppose this is the word, right? So how many letters are there? 1, 2, 3, 4, 5, 6. So it can be arranged in 6 factorial ways. O is appearing twice, L is appearing thrice, right? So it will be divided by, so O is arranged in 2 ways, 2 factorial. L is arranged occurring 3 times, so 3 factorial. Okay, so this is the idea behind the 2 statements written over here. Okay, so now we will read out those 2. I hope you have understood this one. So distinct objects means all letters or all the objects will be different, right? So, and not distinct means they won't be different. Some will be similar, right? As in case of MAT and MAA, right? So now look here. The number of permutations of n objects where p objects are of one kind. If p is of one kind, then it will be n factorial by p factorial. If no more number of similar objects are present, this statements in a more general way, the number of permutations or arrangements of n objects where p objects are of one kind, right? P2 are of second kind, P3 are of third kind, up to the last, PK are of kth kind, and the rest are different. So such type of arrangements are n factorial by P1 factorial, P2 factorial, so on up to Pk factorial. So always remember, always understand. Okay. So first example was rows, right? First example, the very first example, and you can observe here, right? All the letters are different, all the letters are distinct, and you can check all the questions whatever we have solved till now. It was the case of distinct objects only. All the objects were different only, right, students? But from here onwards, you can see there are some cases where the given word or the given objects are similar, not distinct. Okay, so now today we have discussed MET also, right? This is also distinct, but this is not distinct, right? So, and this is also not distinct. Okay, why? Because L is of one kind and it is appearing twice, and A is of one kind and it is appearing four times, and the rest are different. This is one time occurring, this is one time, this is one time. Right. So now you have to even keep in mind while reading the questions, while looking at the questions, whether the objects given are distinct or not distinct. Okay. So now with this, we shall start with the problems. Okay. Okay. Example 9. Yesterday we have not solved example 9, right? It was because of this only. Okay. So example 9. Find the number of permutations. Find the number of permutations of the letters of the word Allahabad. Okay, so from here onwards, now you understood you know that there are two cases, distinct objects and not distinct objects, right? So now keep in mind, whenever the question is given, just look at the question very carefully. Okay, so now if you observe here, find the number of permutations, means in how many ways we can arrange the letters of the word. That means all the letters of the word Allahabad. So now tell me, does it contain distinct letters? No, students, because here L is appearing twice and A is appearing four. Okay, it appearing four times. So here all are not different. Okay, all the letters in the word Allahabad are not different. Some are similar. Okay, and because of some letters being similar, the formula what we need to take is n factorial by p factorial. If it's only one over there which is similar, or if there are many, n factorial by p1 factorial, p2 factorial, so on up to pk factorial. Okay, so now let's solve the solution. The word Allahabad, the word Allahabad, right? So now first let us count how many letters are there. Okay, so these are 3, 6, 9. So the word Allahabad has 9 letters, right? In which a letter is of one kind, right, students? In which A is of one kind. So how many times it is appearing? Twice, right? And A is of four times. A, 1, 2, 3, 4. A is of one kind, right? So it is appearing four times. Now, is there any other letter that is appearing more than once? L. L is of one kind, right? So it is appearing twice. Okay, so now the rest all are different. Right. So if how many letters are there? Total letters are there 9. So hence the total number of ways. The total number of ways is equal to. So what's the formula? N factorial by divided by the similar kind factorial notations. Okay, n factorial by p factorial, or you can use n factorial by p1 factorial, p2 factorial, so on up to pk factorial. So total number of ways. So how many are there total? 9 factorial. But since a is appearing 4 times, 4 factorial. L is appearing twice, 2 factorial. Okay, students. So now simplify this one, right? So 9 into 8 into 7 into 6 into 5 into 4 factorial, whole divided by 4 factorial into 2 factorial, right, students? So 4 factorial get cancels, right? So which is equal to 9, 8, 7, 6 divided by 2 factorial. So 2 factorial is nothing but 2 into 1, right, students? 2 into 1, right? So now keep on simplifying. 2 ones are 2 threes are 9 8s are 72. Okay, 9 8s are 72 into 7 3s are 21. Now simplify this and check what will be the answer. The answer will be 7 5. Okay, just simplify this one. The answer will be, okay, just multiply it. 7560, right? Let me verify it. Okay, let me solve and see. Let us. Okay, so now let us simplify here. It's not visible over there. So let me simplify here. So 9 factorial, right? So it was 9 factorial by 4 factorial into 2 factorial. 9 factorial divided by 4 factorial into 2 factorial. 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial. Right, students? Right. So now 4 factorial get cancels. 9 into 8 into 7 into 6 into 5, whole divided by 2 factorial. So 2 factorial is nothing but 2 into 1. Okay, so now just simplify this again. So 2 fours are you can strike, or 2 threes are your wish, right? So it will be 9 into 8 into 2 ones are 2 threes are 9 into 7 into 3 into 5, right, students? So 9 8s are 72 into 7 3s are 21 into 5, right? So now multiply this. The what will be the answer? So it will be 7560. Okay. So this is how you solve the questions when the letters given or in the word contains not similar objects. Okay, so it has to be, when it is similar, you have to use such type of formulas. So now one more question. Example 10 we have solved yesterday itself. Example 11. Example 11. How many numbers lying between lying between 100 and 1000 can be formed with the digits can be formed with the digits 0 1 2 3, 4, 5. If the repetition of the digits, if the repetition of digits is not allowed, if the repetition of digits is not allowed, so the question here is, how many 4-digit numbers, how many, okay, 4 digits, sorry, how many 4-digit numbers are lying between 100 and 1000? Sorry, correct, sorry. How many numbers lying between 100 and 1000 can be formed with the digits 0, 1, 2, 3, 4, 5 if the repetition of the digits is not allowed? So they are asking us how many numbers are lying, how many numbers are between 100 and 1000 students, right? So between 100 and 1000, how many different numbers do we have? Okay, so between 100 and 1000, so after 100 it will starts with 101, right? Then 102, then 103, and they are saying between, in between 100 and 1000, right students? In between 100 and 1000. So these, between these two, right, between these two, these are the extreme numbers. So what will be that? A number before to the 1000, 999, right? How many such numbers are there? 3-digit numbers are there, we need to write down. Okay, so here, so what you can see, between 100 and 1000, these are nothing but 3-digit numbers. So that means out of the digits given, you have to form a 3-digit number. And always be careful from now. Are the given letters or the numbers distinct or no? Okay. So here all are distinct. All are distinct means all are different. 0, 1, 2, 3, 4, 5. No number is appearing more than once here, right? So now we have to form a 3-digit number out of the given 6-digit, and always be careful in reading the questions. So in this we have how many digits? So we have 6 digits, right? So what are those? 0, 1, 2, 3, 4, 5, right? So now we understood between 100 and 1000, in between 100 and 1000, how many digit numbers are there? 3-digit numbers. So 3-digit numbers means 3 boxes, fundamental principle of counting, right? So this is our units place, this is our tens place, this is our hundreds place. Is that clear, students? So now look at the the numbers which we are having: 0, 1, 2, 3, 4, 5, right? So the condition here is 3-digit you have to form out of this. So but be careful, if you take 0 at the first place, if we fix 0 at the first place, so it will be nothing but a 2-digit number, right? So we have to form a 3-digit number. We have to form a 3-digit number. But in the given collection, there is a digit 0 also. If this 0 appears in the tens place, right? Okay, in the tens place, it doesn't matter, right? If this 0 appears in the last place, also doesn't matter, because this will be read as 101, this will be read as 210, right? So this will be read as 201, right? 200, that is also possible. But what if, right? So what if in the first place itself, if we fill 0, right? So now let me keep this different, right? So now look here, There are three digits, but is it a three digit number, students? It's just 21, and this is just 63. This is 78. This is 99. So first and foremost thing is that the hundreds place cannot be filled by the hundreds place cannot be filled by cannot be filled by 0. That means except 0, you can fill anything in the hundreds place, 1, 2, 3, 4, or 5, right? So hence to fill hundreds place to fill hundreds place. So how many are there? 1, 2, 3, 4, 5. So you can fill it in 5 different ways, right? And the digits is not allowed. Repetition of digits is not allowed. So you cannot repeat the digits. So among this, let me suppose among this, one letter is being used here. So how many we are left with now? 1, 2, 3, 4, 5. And again, here you can take 0. It doesn't matter, right? So we are having 5 now. The tens place can be filled in how many ways? 5 ways, right? So now the digits cannot be repeated. So let me suppose this is being filled. So the units place can be filled in how many ways? 4 ways, right, students? So hence the total number of ways is equal to 5 into 4, right? So 25 into 4 is equal to 100. So there are 100 possible 3-digit numbers between 100 and 1000. Okay, we can form out of 0, 1, 2, 3, 4, 5. So this is our example 11. Now example 12, right? Example 12. Find the value of n such that so first one in the 12th example, first bit, np5 is equal to 42 np3 and n should be greater than 4 only. Okay, so n should be greater than 4 only. So this is important here. Okay, so the first bit in the 12th example is np5 is equal to 42 into np3, n greater than 4. So why they have given n greater than 4, we shall understand. So now first, what happens if we take n less than 1? Let's see. So n less than 4, right? So in this equation less than 4 I'll take. So what is that number? 3, right? So 3 P5 equal to 42, 3 P3, right? So this is anyhow. 3 you can arrange out of 3. But can you arrange 5 objects out of 3 objects? So this left hand side fails, right? So that's why they have given a condition. So always n has to be greater and r has to be smaller, or r can take. So that's what we have done previously. R can take between 0 to n. Okay. So now using formula, let's simplify. What is np5? N factorial by n minus 5 factorial, which is equal to 42. np3. So what's the formula? N factorial by n minus r factorial, students. N factorial by n minus 3. Right. So now let's keep on simplifying this. Right. So now this will be, so when you cross multiply n factorial, n, now just cross multiply or else simplify, right? N into n minus 1, students, n minus 2, n minus 3, n minus 4, n minus 5 factorial. I'll stop here itself. N minus 5 factorial, which is equal to 42 n factorial, n into n minus 1, n minus 2, n minus 3 factorial, right? So divided by n minus 3 factorial. Yes, students. So now n minus 5 factorial, n minus 5 factorial get cancels, and here n minus 3 factorial and n minus 3 factorial. So what we are left with now? N into n minus 1, n minus 2, n minus 3, n minus 4, which is equal to 42 n into n minus 1, n minus 2. Right, students? Now if you observe carefully, n into n minus 1 into n minus 2 are on the both the sides. I can cancel them. So what will be n minus 3, n minus 4 equal to 42. Now let's keep on simplifying this until we get n. Okay. So now there is no space. I'll erase and write it above. So n minus 3 into n minus 4 equal to 42. Right, students? Now multiply this. N into n square. Right? N into minus 4, minus 4n, minus 3 into n, minus 3n, minus 3 into minus 4, plus 12 equal to 42. Right? So n square minus 4n minus 3n. So what will be the answer? Minus 7n plus 12 minus 42. So 42 I will shift to the left hand side. N square minus 7n. So 12 minus 42. So subtract 12, 42 from 12. Right? So what will be the answer? Minus 30 equal to 0. So now we are reduced to a simple quadratic. Now we are reduced to a simple quadratic equation. Right. So now we shall solve what is n. Right. So this is nothing but, so factorize it, right? You know it. So n square, it's very easy, right? So multiply in such a way that I'll get minus 30, right? And when you add or subtract, when we add or subtract, we should get minus 7. So minus 10. Minus 10 plus 3. Minus 10n plus 3n minus 30 equal to 0. Right. So now from this 2, can I take n common? N minus 10 plus. So from here I can take 3 common. N minus 10 equal to 0. Right. So now n minus 10 can be taken common. So from in this part, what is left? N. And from this part, what is left? 3 equal to 0. Right. So n minus 10 equal to 0 or n plus 3 equal to 0. So what is n here? N is equal to 10 or n equal to minus 3. So what's the value of n, students? The value of n is either n equal to 10 or n equal to minus 3. Okay. So but among these two, which is right one we need to understand. Both might be right, or one may be right, or one may be wrong. Okay, so n is equal to 10. So objects must be positive, right? Objects cannot be negative. You cannot say arranging 3 things out of minus 10 things. So what is that minus 10? Minus 10 objects. Minus 10 objects doesn't make sense. So negative is to be neglected. So this is not the right answer. Right? So it has to be positive. N has to be positive only. So for this question, the value of n is 10. Okay, students? So, so now second one. Second one we shall see. It's very smooth. Second one, find the value of n such that np4 by n minus 1 p4 equal to 5 by 4, where n is greater than 4. Okay, students. So now look here, what is n? So first let us cross multiply. 4 into np4 is equal to 5 into n minus 1 p4. So just apply the formula, npr formula, n factorial by n minus 4 factorial. Yes, students, 5. Right. So in the place of n it is n minus 1 now. So this will be n minus 1 whole factorial divided by, so what is n here? N minus 1. N minus 1 minus r. So what is r here? Minus 4 factorial. Yes, students. So now can I say minus 1 minus 4 is nothing but minus 5. So I'll write this as n minus 5 factorial. Okay. So now 4 into, right? So n into n minus 1 factorial, right? So can I write n factorial as n into n minus 1, n minus 2, n minus 3, n minus 4, so on up to 3 into 2 into 1, right? So but I'll stop here itself, n minus 1 factorial, because on the right hand side I have n minus 1 factorial also, and here n minus 4 factorial, right? So it starts with n minus 4 and keeps on reducing by minus 1. So can I write this as n minus 4 into n minus 4 reduced by 1, right? So minus 4 minus 1 is nothing but minus 5, right, students? So which is equal to 5, n minus 1 factorial by n minus 5 factorial. Now you can see n minus 1 factorial, n minus 1 factorial, and this n minus 5 factorial, this n minus 5 factorial get cancels. So 4n by n minus 4 is equal to 5, right? So 4n is equal to, cross multiply, students, 5 times of n minus 4. So 4n is equal to 5n minus 5 fours are 20, right? So shift this side, 5n minus 4n minus 5n is equal to minus 20. 4n minus 5n minus n minus 20. So n is equal to 20. So the value of n in the second bit is 20. Thank you, students. We shall start doubt sessions. Okay, students, this particular problem, actually it was np4 by n minus 1 p4 is equal to 5 by 3. Right. So I taken it for this is also right. The question is right, and the answer is simplification also is done correctly only. Okay. So it's like one extra problem we have solved here. So don't worry. Tomorrow I shall solve np4 by n minus 1 p4 equal to 5 by 3. Okay. 12th one. 12th one first bit np5 is equal to 42 np3 n greater than 4. So this is the mathematical equation. Okay, so they are asking us to find out what is the value of n. So first one, np5 is equal to 42 np3. So what's the formula of npr? N factorial by n minus r whole factorial. Yes, students. Okay, so now using this formula, we shall solve the given expression. So n factorial by n minus 5 factorial, which is equal to 42 into n factorial by n minus 3 whole factorial. Right, students? Okay, so n factorial. Okay, so if you see here, we can reduce one more step also here. N factorial we can cancel. Yes, students. So n minus 5 whole factorial, which is equal to 42, 1 divided by n minus 3 factorial. Right, students? So cross multiply now. N minus 3 whole factorial, which is equal to 42 into n minus 5 factorial. Right? So now I will open up this factorial notation. So 5 factorial, how will you write it down? 5, it starts with 5, then reduces by 1 into 4, into 3, into 2, into 1. So what you can see here is, it is being reduced by 1. So here also same, students. So n minus 3, it starts with n minus 3. Okay, then in the next place it gets reduced by 1. So minus 3 minus 1 minus 4, students. So minus 4. Now again in the next place n minus 4. So again it is reducing by minus 1. So minus 4 minus 1 minus 5. Yes, students. So here itself I will stop. I will stop it here, because on the right hand side I have a term n minus 5 factorial, so that the cancelling will be easier. Right? Now let me cancel these two, remove these two in the next step. So it will be n minus 3, n minus 4 is equal to 42. Is that clear now till here? So from here we shall solve further. Okay. So now multiplication of the expression. So n into n square. Right. First multiply the n with the second bracket. Right. N into n square. N into minus 4n, then minus 3 into n minus 3n, then minus 3 into minus 4 minus 12 equal to 42. So n square, right? So minus 3 into minus 4 is plus 12, students. Minus 4n minus 3n minus 7n plus 12 minus 42, shift this side, minus 42, n square minus 7n minus 30 equal to 0. Yes, students. So now observe here, this is nothing but a quadratic equation. We'll have two values of n. So factorize it. So n square is having a coefficient 1. If it's nothing over there, it means 1, right? 1 into minus 30, minus 30. Now multiply two numbers in such a way that I'll get minus 30, and when you add or subtract, you get minus 7. So minus 10, 3, right? N square minus 10n plus 3n minus 30 equal to 0, right? So n square minus, right? So now take common here. n minus 10 plus 3, n minus 10 equal to 0, right? So n minus 10 can be taken as common. N minus 10, n plus 3 equal to 0. So now equate these terms, n minus 10 equal to 0 or n plus 3 equal to 0, which implies n equal to 10 or n equal to minus 3. The number of objects cannot be negative, so just ignore this. So the answer is n equal to 10. Okay. Second one. So second one also students have doubts. So the second bit is np4 divided by n minus 1 p4, right, which is equal to 5 by 3, 5 by 3, and n is greater than 4. Okay, so now use the formula, or first cross multiply them. 3 into np4, which is equal to, cross multiply, 5 into n minus 1 p4, right? So now apply the formula, n factorial by n minus 4 factorial, right? So what's the formula? General formula, npr is equal to n factorial by n minus r factorial. But in this case, our n is nothing but n minus 1. So it will be n minus 1 factorial divided by, what's the, okay, so n factorial by n minus r whole factorial, right? So our r is, so our n is n minus 1 here. So that's why replacing n by n minus 1 factorial. So here also n minus 1. So minus r. So what is r here? 4. Minus 4 factorial. Yes. So 3 into n factorial by n minus 4 factorial, which is equal to 5 into n minus 1 factorial divided by n minus 1 minus 4 minus 5, students, minus 5 factorial, right? So from here we shall simplify. Okay. Okay, whenever you are solving factorial problems, keep observing at each and every term, so that in cancelling out, in simplifying, it will be very easier, right, students? So n factorial, n factorial means it starts with n. then n minus 1, n minus 2, n minus 3 up to 3 into 2 into 1. So n into n minus 1, n minus 2, n minus 3. I won't write further. I will stop here itself. N minus 1 factorial, because on the right hand side I have n minus 1 factorial whole divided by n minus 4 factorial, which is equal to 5 into n minus 1 factorial whole divided by n minus 5 factorial. Right. So now n minus 1 factorial, n minus 1 factorial get cancels. 3n by n minus 4 factorial, which is equal to 5 divided by n minus 5 factorial. Right. So now again keep on simplifying. So can I write n minus 4 factorial as? So I have told you in factorial notation, it keeps on reducing further by 1. So n minus 4. So the next will be n minus 4 minus 1. Right? Minus 4 minus 1 is nothing but minus 4 minus 1 is nothing but 5. N minus 5 factorial, which is equal to 5 divided by n minus 5 factorial. So this n minus 5 factorial, this n minus 5 factorial get cancelled. So we are reduced with 3n by n minus 4, which is equal to 5 divided by 1. Right? So now just cross multiply it. So 3n. Okay. So cross multiply. So 3n into 1, 3n. 5 into n minus 4. 3n is equal to 5n minus 20. Right? So 3n minus 5n is equal to minus 20. What I have done, I have just shifted 5n to the left hand side and grouping like terms together. 3n minus 5n minus 2n equal to minus 20. Right? So n is equal to minus 20 by minus 2, which is equal to 10. So this is the answer. Okay, students, I hope there are few more doubts. Okay, don't worry. Tomorrow in the beginning, I'll clear those and then start and solve the remaining problems.